Hello, welcome to Lesson 4, Scatter Plots. So for the first question, it is pretty straightforward. It's to test your understanding of essentially reading a scatter plot. So if you look closely, it says, reading the first question, this graph compares the time since your team started walking in a 24-hour relay and the distance covered. So you see here distance and time. So question A asks, what distance was covered after 12 hours? So remember, the time here is our independent variable, which means it is on the x-axis. What in the world is an independent variable? You'll find out more about that later. But essentially, it's as the word sounds, independent, something that does not depend on something else. Time does not depend on anything, whereas the distance depends on, well, the time. And as you've guessed it, this variable would be called the dependent variable. Now, A, what distance was covered after 12 hours? We simply look at the time, we see 10 hours, 11 hours, 12 hours, and if I go up, I see here the distance that was covered, and I cut across there, and I see it's roughly 48-ish, a little higher than 45, okay? Now, for the rest of the questions, it's very similar to that. Now, for question 2, it requires a little bit more work. For question 2, we are asked, in fact, I don't think I have to zoom in on that. You can read on your paper there. It says, the table shows the average time spent watching TV per week and the math mark of 15 students. Put the time on the x-axis and put the mark on the y-axis. Okay? So for A, it's asking us to make a scatter plot of the data and draw a line of best fit. So time is across the bottom here. It is our independent variable. Okay? So as it said in the original question, put the time on the x-axis, put the mark on the y-axis. So that's our x-axis at the bottom. The line that runs horizontally, time. Now the line that runs vertically would be our mark. Okay, so mark, M-A-R-K, in percentage. Okay, so here's where we need to be a little more strategic. So let me try to zoom out here. Okay, so if we look at the time row, okay, so as you can see here, the top row represents the time. So we see we have 5 hours, 12 hours, 9 hours, 6 hours, 21 hours, and so forth. If you look across here, the fewest amount of hours would be 0. Whereas the highest amount of hours would be 21. Okay, it just so happens that they're beside each other. Total coincidence. Well, why did I mention that? Well, if we look back at our graph for the x-axis for the time, we know that from 0 to 21, it needs to be covered in here. Okay, so would it be a good idea to go up by ones? 1, 2, 3, 4? No, it wouldn't. We wouldn't get to 21. Maybe twos. 2, 4, 6, 8, 10, 12, 14. That might work a lot better. We can go by 5s if we want to, 5, 10, 15, 20, but then our graph would stay in here and we waste all this space. Okay, so let's go up by 2s. So let's go 2, 4, 6, 8, 10, 12, yada yada. Okay, I'll let you do the rest. Now, once again, let's look at the marks. If we look at the marks here, we see we got 85, 56, 76, 73, 45, yada yada. Okay, now the marks we're going to assume start at a 0 and go to 100 because we're looking at percentages, right? So once again, we could go up by, well, we can't go up by 1s because it wouldn't fit. We could go up by 2s, could go up by 3s, could even go up by 5s, but let's see which one is the most reasonable. Let's see if we went up by 5. Let's see what happens. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So it would work. Okay, and in my opinion, that would probably be your best option. If we went up by 2s, 2, 4, 6, 8, 10. That's already 10. We need to go up to 100. Okay, so let's go with 5s. So once again, I'm not going to put them all in. 5, 10, 15, 20. Actually, I might. 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. Ooh, it's a bit of a tight squeeze here, eh? 95, 100. So as you can see here, I went up by 5s, okay? Now, to plot a scatter plot, we always start with the x's, okay? Think about the alphabet. X always comes before y, okay? So all these represent coordinates. So if you look at here, if someone spent 5 hours watching TV, their mark on average would be about 85%. 5 hours, I believe this is a week. Yes, per week. Okay, 5 hours per week, their mark is on average 85. Someone who watches 12 hours, their on average is 56. Okay, actually, no, sorry, I lied. Not on average. These are particular students. So one student who watches 5 hours has got an 85%. One student who watches 12 hours got 56%. Now it says make a scatter plot of the data. So using that point there, I'm going to make a scatter plot. So the first point will be 5, 85. So 5 representing the time in hours, 2, 4, 5 would be about there, and their mark is an 85. So if I go up, up, and using my fingers, in fact, let's even use a pencil crayon. Okay, so 5, up to 80, 85 is there. Now I don't know if you can see it on in the video. Let's move it up. There we go. So 5, up to 85, right there. That is 1 point. Okay. Here we look back here. Someone who watched 12 hours got a 56% in the class. So if we look at the bottom here, 12 hours and 56%, I shouldn't have to go very far up. Right there. That's another point. Alright, okay, so I'll let you finish the rest. And the rest of the questions just, or not test you, but it enables you to see if you can understand what the scatter plot is about. Okay, have fun.